Google just did something that should have broken the internet. Their quantum computer didn't just solve a math problem. It didn't just beat a record. It did something that scientists are quietly calling one of the most disturbing discoveries in human history. It cracked open a door that we were never supposed to open. And what's behind that door? The possibility that everything you see, everything you touch, everything you think is real is not. It's code. It's data. It's a simulation running on something so far beyond our understanding that we don't even have the language to describe it yet. Let's go straight into it. Google's quantum computing division, Quantum AI, has been pushing boundaries for years. But in their latest breakthroughs, something shifted. They weren't just computing faster. They were computing differently. In a way that starts to mirror how the universe itself seems to operate at the deepest level. And when you put those two things side by side, quantum mechanics and the behavior of Google's most advanced quantum processors, the conclusion that keeps coming up again and again is almost too strange to say out loud. The universe behaves like a computer program, not metaphorically, not as a poetic comparison, literally, mathematically, structurally. Here's where it starts. Quantum mechanics, the science of the very small, has always been weird. Since the early 1900s, physicists have known that particles don't behave like tiny billiard balls. They exist in superpositions, meaning they can be in multiple states at once until you observe them. When you look at a particle, it chooses a state. When you're not looking, it exists in all possible states simultaneously. That's not a theory. That's been proven in laboratories thousands of times. Now here's the disturbing part. That is exactly how a computer simulation would work to save processing power. Think about it. In a video game, the game doesn't render what you can't see. It only loads and processes what's in your field of view. Everything else exists as potential data, not rendered reality. The moment you turn around, the game renders that space. The moment you look away, it stops. Quantum mechanics works the same way. Particles don't have a definite position or state until observed, until measured, until something interacts with them. It's as if the universe is only rendering what's being looked at and leaving everything else in a superposition of potential data. That is not a coincidence that scientists are comfortable with. That is a feature. And features are designed. Now Google enters the picture. Google's quantum processor, Willow, unveiled in late 2024, achieved something that classical computers cannot do in any reasonable time frame. It solved a specific computational benchmark in under 5 minutes, a problem that would take the fastest classical supercomputer on Earth 10 septillion years to solve. That number is not a typo. 10 septillion years. The universe is only 13.8 billion years old. Willow solved it in 5 minutes. But that's not the part that matters most. The part that matters is how it did it. Quantum computers work by using qubits instead of classical bits. A classical bit is either a 0 or a 1. A qubit can be both simultaneously, thanks to superposition. When you scale that up to dozens or hundreds of qubits, you get a machine that can process an astronomically large number of possibilities at the same time. But here's where it gets philosophically dangerous. When Willow performs its calculations, where are those calculations actually happening? Physicists have a serious answer to that question, and it is not inside the chip. David Deutsch, one of the founding fathers of quantum computing and a physicist at Oxford, has argued for decades that the only coherent explanation for how quantum computers work is that they are performing calculations across multiple parallel universes simultaneously. The quantum computer in our universe handles part of the problem. Versions of that same computer in parallel universes handle other parts. The answer arrives here because the computation happened everywhere. If that's true and the math supports it being true, then the universe is not a single isolated system. It is one thread in an unimaginably vast computational structure. And Google just built a machine that taps into that structure. Now let's connect this to the simulation hypothesis properly, because most people get this wrong. The simulation hypothesis is not a conspiracy theory. It is a serious philosophical and scientific proposition supported by some of the most respected thinkers alive. Nick Bostrom, a philosopher at Oxford, laid out the logical case in 2003. His argument is simple and almost impossible to escape. One of three things must be true. Either almost all civilizations destroy themselves before reaching the technological level needed to run realistic simulations of reality, or civilizations that reach that level have no interest in running such simulations, or we are almost certainly living in a simulation right now. The logic is straightforward. If even one civilization in the history of the universe ever reaches the ability to simulate conscious beings in a virtual reality, and if they run even a handful of such simulations, then the number of simulated beings immediately and permanently outnumbers the number of real beings. Statistically, you are almost certainly simulated. The odds of being a base layer biological organism are vanishingly small compared to the odds of being one of trillions of simulated minds. And now quantum computing is giving that argument new and terrifying teeth. Because here is what Google's work is revealing at a technical level. The universe has a resolution limit. There is a smallest possible distance, the Planck length, below which space itself has no meaning. There's a smallest possible unit of time, Planck time, below which moments cannot be divided. The universe is, in the most precise technical sense, pixelated. It has a maximum frame rate. It has a minimum render distance. Every simulation has these features. Every game, every virtual reality, every computational model has a point beyond which you cannot zoom in further. The world ends at a certain resolution. And our universe ends at the Planck scale. That is either the most extraordinary coincidence in the history of thought, or it is a design specification. There's more. The laws of physics are mathematical. Not approximately mathematical. Not mostly mathematical. Perfectly, completely, absurdly mathematical. Physicist Eugene Wigner famously called this the unreasonable effectiveness of mathematics. The fact that abstract mathematical structures invented by humans with no practical purpose in mind keep turning out to describe physical reality with perfect precision. Why would a universe that arose randomly from nothing be perfectly described by mathematics? Why would it follow rules at all? A simulation would follow rules. A simulation would be mathematical at its core because mathematics is the language of computation. The fact that our universe is not just approximately, but precisely mathematical at every scale we can measure is exactly what you would expect if the universe were running on mathematical substrate. If it were, in fact, code, and Google's quantum AI work is making this weirder. Their research into quantum error correction is one of the most significant recent developments. Quantum systems are fragile. They lose their quantum state through a process called decoherence. Interaction with the environment destroys the superposition. For years, this was the main obstacle to building useful quantum computers. Google has been solving this problem, and the way they're solving it involves something called topological qubits and error-correcting codes. Here's the disturbing part. The universe itself appears to use error correction. Physicists studying quantum gravity have discovered that the mathematical structure of space-time behaves like a quantum error-correcting code. Specifically, theoretical work connecting quantum entanglement and the geometry of space-time, summarized in the equation ER equals EPR, suggests that the fabric of space itself is built from entangled quantum information that is protected against errors in the same way a sophisticated computer system would protect its data. The universe is not just mathematical. The universe appears to be running error correction on itself. It is maintaining the integrity of its own code. That is not a feature of random physical reality. That is a feature of engineered systems. Now let's talk about consciousness, because this is where it gets personal. If the universe is a simulation, then consciousness is either an emergent property of the code, something that arose from sufficiently complex information processing, or consciousness is something that was deliberately built in, a feature rather than a bug. Either way, what you experience as your inner life, your thoughts, your sense of being a self who is experiencing something right now, that is information. It is data being processed. And if it is data, then it can in principle be copied, transferred, modified, or ended by whoever or whatever is running the simulation. That is not a comfortable thought, but comfort is not the same thing as truth. Google's AI research is also relevant here in a way that people have not fully appreciated. Their large language models and AI systems are demonstrating something remarkable. When you train a sufficiently large AI system on enough data, it begins to exhibit behaviors that were not explicitly programmed. It develops what appears to be understanding. It makes connections, generates novel ideas, shows something that looks uncomfortably like creativity and reasoning. This is called emergent behavior, properties that arise from complexity that were not designed in but simply appeared. If consciousness can emerge from silicon and code in our own computers, then the argument that consciousness cannot emerge from a sufficiently advanced simulation of a universe becomes very hard to make. And if consciousness can emerge in a simulation, then the beings running the simulation have created something morally significant. They have created minds that suffer, that love, that fear, that hope. Whatever is above us, whatever civilization is running this universe, if it is being run, has made something that matters. That is either the most terrifying or the most meaningful idea in human history, depending on how you look at it. Let's bring this back to Google specifically. What Google's quantum AI division is building is not just a faster computer. They are building a machine that operates on the same fundamental principles as the universe itself: quantum superposition, entanglement, interference, error correction. These are the operating principles of quantum computers, and they are the operating principles of physical reality. Google is essentially reverse engineering the computational substrate of the universe, and as they get better at it, as the qubits scale up and the error rates drop and the coherence times grow longer, they are going to be able to simulate more and more complex quantum systems. Eventually, not in 5 years, but in decades, quantum computers will be able to simulate entire molecular systems, then chemical processes, then biological systems, then brains. The endpoint of this trajectory, followed long enough, is the ability to simulate a conscious mind inside a computer. At that point, the simulation hypothesis stops being a hypothesis. It becomes a capability. And once it becomes a capability here in this universe, the argument that it hasn't already happened somewhere above us collapses entirely. The question is not whether simulation is possible. We are learning that it is. The question is whether it has already been done. And the answer, statistically and philosophically, is almost certainly yes. So what do we do with this? Some people hear this and feel meaninglessness. If it's all a simulation, does anything matter? But that gets it exactly backward. If this is a simulation, then everything that happens here is real data in a real system. Your experiences are real. Your relationships are real. Or the joy and pain you feel are real computations happening in a real system. The fact that the substrate is code rather than atoms does not make the experience less real. Your emotions are real regardless of what generates them. And if there is a simulator, if there is something or someone above this universe, then we are the most interesting thing they created. We are the part of their system that became aware, that looked up at the sky and asked why, that built quantum computers and started to glimpse the architecture of our own existence. If they're watching, we just did something extraordinary. We knocked on the wall of our own reality and asked if anyone was on the other side. Google's quantum AI didn't just solve a computational problem. It pulled back a corner of the veil. It showed us that the deepest layer of reality, the quantum layer, the layer where particles exist in superposition and entanglement connects things across space, operates according to computational principles. And if the deepest layer of reality is computational, then the most honest and scientifically coherent answer to the question, what is the universe, is this. It is a program. It is running. We are in it. And we are only now, for the first time, beginning to understand the language it was written in. The universe gave rise to beings who built machines that can think quantum mechanically, machines that operate by the same rules as reality itself. And those machines are now starting to decode the structure of the world they were built in. That is either the most profound scientific moment in human history, or it is the moment we were always supposed to reach, the moment written into the code from the beginning. Either way, nothing will ever look quite the same again.